Hello everyone. So this video we're just going to look at several examples of writing trigonometric ratios in equivalent forms. So what I mean by that is if I have secant squared theta minus tangent squared theta, I can probably write this in a way that is simpler. So one method is to use the reciprocal identity. So like secant squared is just 1 over cosine squared theta. And I can do the same thing with tangent squared using the reciprocal identities. So that would be sine squared theta over cosine squared theta. Now, if I am looking at this, they have the common denominator now. So I can now write this as 1 minus sine squared theta over cosine squared theta. But then, if I remember the Pythagorean identities, one of the Pythagorean identities is sine squared theta plus cosine squared theta is equal to 1. And if this is true, or since this is true, that means that 1 minus sine squared theta must be cosine squared. So I can rewrite this again as cosine squared theta over cosine squared theta. And since those are exactly the same, this is 1. Now, there is another way of going about this, and it's using a Pythagorean identity. Because sine squared theta plus cosine squared theta equals 1, that means that tangent squared theta plus 1 is secant squared theta. But if this is true, or since this is true, that means that 1 equals secant squared theta minus tangent squared theta, which means that we can just say that this is 1. So the big thing here is that there are multiple paths to get to where we want to go. And depending on what we are given will help us determine what route we should take. And sometimes it's more clear than others. Let's look at cosine theta minus secant theta divided by sine theta. So this is one where it is probably going to be easiest to try to write the numerator as a single value before we do anything else. So we're just going to use the reciprocal identities. Well, cosine I'm just going to keep as cosine theta. But secant I'm going to write as 1 over cosine theta. And that is all still over sine theta. Now, For the numerator, I would need a common denominator. The common denominator is going to have to be cosine, which basically just means that I'm multiplying over here by cosine theta over cosine theta. Or another way of saying that is I'm multiplying by 1. So this would give me cosine squared theta minus 1 over cosine theta. And that is all over sine theta. Now we're going to think back to our Pythagorean identities, specifically sine squared theta plus cosine squared theta equals 1. So I can write sine squared theta as 1 minus cosine squared theta. But that isn't quite what I have up here. I actually have cosine squared theta minus 1. But that is really just this value here multiplied by negative 1, which means that this numerator is actually just negative sine squared theta, and it's still over cosine theta, and it's still over sine theta. Now, depending on how comfortable you are working with fractions, you might want to write this out, you might not, but negative sine squared theta over cosine theta times 1 over sine theta. Because if I divide by sine, I multiply by the reciprocal. Notice that this is going to cancel out one of my signs I have there and this sign, leaving me with negative sine theta over cosine theta, which means that this cosine theta minus secant theta over sine theta is actually just the tangent of theta. So again, these can be done in multiple ways. We could have started off by, instead of thinking of this as sine theta, we could think of it as cosecant, or 1 over cosecant theta. And then we could have multiplied by that, and we could have simplified down from there. I don't know if it would have been simpler or not, but we do have options. Let's look at one that involves some factoring. Let's look at, actually, let's not look at one that involves factoring. Let's look at one that involves us to combine some fractions. So let's say we have 1 plus sine theta over cosine theta. And we're going to add to that cosine theta over 1 plus sine theta. Okay. So the thing that's going on here is I have two fractions, and whenever I have two fractions that I'm adding together, if I can find a common denominator, I can write them as a single fraction. So my common denominator in this case is going to be cosine times 1 plus sine theta. So if I'm using that, that means I'm going to multiply this side by 1 plus sine theta over 1 plus sine theta, because I need to multiply by 1 to not change anything. And this one I'm going to multiply by cosine theta over cosine theta. So I now have 1 plus sine theta squared plus cosine squared theta over cosine theta times 1 plus sine theta. Now, we might want to, with our numerator here, expand this out a little bit. So, if I'm squaring a binomial, we should know that that gives us 1 plus 2. Sine theta plus sine squared theta plus cosine squared theta. And this is still going to all be over 1 plus sine theta times cosine theta. Okay, so this part right here, sine squared theta plus cosine squared theta, that is just 1. That means I have 2 plus 2 sine theta in my numerator. And in my denominator, I have 1 plus sine theta times cosine theta. And actually, we are going to have to do a tiny bit of factoring on this one. So, 2 is the greatest common factor of my numerator, so I'm going to write 2 times 1 plus sine theta. And that's going to be divided by 1 plus sine theta times cosine theta. Well, I see that I can cancel out those values, meaning this is just 2 over cosine theta. And 2 over cosine theta is really just 2 secant theta, which I'll write just so it's a little clearer down here, 2 secant theta. So what I hope that you are getting from this is that the things that we need to know when we are simplifying down trigonometric statements, or if we're rewriting trigonometric statements in an equivalent form, we need to know a lot of stuff. First, we need to know the identities. And as I said in a different video, if you search for trigonometric hexagon, it should give you a method to help you remember them. If that particular method doesn't work for you, find something. There's ways out there to help you remember these identities. You need to know how to combine fractions. You need to know how to
Will Jane Okonkwo please come to the front lobby?
My apologies for the announcement. We need to know how to factor polynomials. We need to know how to multiply binomials or multiply polynomials in general. And we have to understand this. Understand there is almost always more than one path. We can't just strictly memorize a problem type. Each of these particular things is in a way unique. Yes, there are patterns that come, but ultimately, this is a situation where we are going to have certain things that just kind of hold true. And we're going to have to be very careful and very cautious about how we approach them because of the fact that there are multiple ways of going through all of these problems. Okay, so this video is a little longer than I like, but it is what it is. I hope this video helps as well. And if you have any concerns, please, you can keep searching. I'm going to keep putting videos out as I can and as students ask me to do so. Other than that, I hope that you have a wonderful day, and I will see you in the next one.